All right, so let's jump into the product itself and kind of show you what it looks like. So what you're seeing here on the left is our user interface. So we do have a full GUI as you described in his presentation earlier. And our focus is very much around memory. So our global dashboard is really your global memory dashboard. You can add as many hosts here in the management pane. And what you're getting here on the top is the overall aggregate amount memory and usage for DRAM and for PMEM. Okay, so this is sort of the command view. And from there, you can draw down per host basis. You can look at each host in this list, and then you can see how much memory and operating systems, both from DRAM and the PMEM perspective. And if you further draw down, you can look at the application launched by memory machine, and you can examine the memory, and then you can take snapshots and so on and so forth. So I'm going to start showing you how to use our software. Everything you heard so far is sort of very exciting, and then you may wonder, it's exciting, it's also complicated, but how do you use this, right? So I'm going to give you a Redis example. So normally when you launch Redis, it's just very simple, /Redis server, and then you launch Redis, right? And if you shut it down, you do a Control-C, and it shuts down. So that's the normal way how everyone is using Redis. With our software, all you gotta do is just put in front of it, right? stands for memory machine. Basically wakes up this memory machine on this Linux system, and it's going to manage the memory for this instance of the Redis. And just kind of pay attention to this screen here. So as I launched the Redis instance, you can see here the PID is 18 or 177. The GUI is going to pick up this active running process, and it's going to show you a number of things. It will tell you how much DRAM it's using, how much PMM it's using, CPU and uptime, so on and so forth, right? So that's how you would launch any application with our software. Like other commands on Linux, like df or mount, you can put in front of anything, and it's going to run it just for that duration of that process. Is going to be using our memory machine. So this Redis database is about 8-9 gigabytes. So it's fully loaded from disk. That's the initial loading of this database from file. So you can see here, this is live. And if I do Control-C, this will disappear from the GUI, right? It's all volatile. So this is the transparent memory service, the TMS we've been talking about, right? No application change is backward compatible with any application for memory management. So now what we're going to do is we're going to take a snapshot of this Redis, right? If I take a snapshot, that means if I shut it down, I can bring it back instantly. I don't have to wait. Especially for a very large database, this is very, very attractive. If my database takes half an hour to start, this will take just a second, even less. Okay, so let's take a snapshot. We just click here, take a snapshot. Since this is the first time I'm taking a snapshot, so let me just call it base, so a baseline. To say okay. So you can see here, the snapshot is created. And one of the questions I heard earlier is, how much is the overhead, with your software, right? How much do I have to plan ahead in order to accommodate memory machine? The overhead is extremely small, right? As you can see here, the image size is really the metadata overhead for taking this snapshot. And it's really, looking after this 8 gigabyte of the data on the system. And then that's sort of how you will manage this. In the way, I've been using storage for a very long time. It brings me back the memory of how I using storage snapshotting, storage cloning. You will find that there's a very similar feel of that. Okay, so we have database running. So what I'm going to do is I'm going to generate some workloads, right? It's not very exciting if my database is just sitting idle. So let me just launch a script to to generate a bunch of load. And essentially, it's just pumping in a lot of new data, adding key value pair every second. So while that's happening, I'm going to take more snapshots, right? So I'm going to call it snapshot A. And as you can see here, this snapshot is tracking this delta change in the memory management. And it's also about 2 megabytes. Okay, let's do a couple more. Okay, so there's one, a little bit more data. And as you can see, you can just take many snapshots. And these snapshots is essentially your point in time of the state of this database in the memory. And then we call that the time machine or the DVR, whatever you want to call it. But that is the way you can go back to any point in the history to recover and restore. Okay, so speaking of recover and restore, let's just go ahead and do that. So we have the snapshots, we have our application running. So let's go ahead and then stop it. But before we stop this, let me look at the PID, right? So PID is 18177, 18177. So if I stop the Redis, and if I run this command again, the PID is no longer there, right? So the only way, so one way to get this back is through the snapshot. With console-based application, it's better to do that from the command line. So we will restore the Redis instance from the command line. And this is just exactly the same thing, right? This is the CLI. This is the GUI. They show exact same amount of information. And what we can do now is just say snapshot, and just give a name of the snapshot we want to restore. Okay, so restore finished right away, right? So you can see here the process detached, and the UI is going to update, and then it'll tell you that the application is running again, right? So if I do a PID of Redis server, it's 18177. Right? That's how you would use our product, basically. Okay. I can probably show you about Amazon Cloud real quick. So our software runs in the cloud as well. So this is our GUI running. This is another instance of our software running in the Amazon AWS, and this is the fully quantified name of the GUI. You can see here from AWS, and this is the corresponding SSH session into this application. So this is exactly the same thing what you have seen so far. But one of the things I want to show you is around performance. And you talk about the performance aspect of our software, right? We can essentially deliver DRAM-like performance, and sometimes exceeding DRAM performance using our memory machine. And then you can see how that's the case from here as well. So the particular query I'm running here is basically the KDB KX database, the bulk insert query. And so with the bulk insert, essentially, you can see here, these are the performance metrics on DRAM, right? Slightly over 100 million inserts per second. So now I'm running right? Exact same command, no change in KDB. I start with and everything is now managed, its memory by memory machine. This is a volatile instance of this application. It runs the PID, the process starts and it finishes. When it finishes, it just exits. You can see here, we're running about 167 to 176 million inserts. It's really impressive compared to just from a DRAM perspective. So this is a write-centric workload. And if I quickly switch to a read-centric query, so if I change to read, right? So again, the the read query would be my my benchmark, run all on DRAM, and then you will see it's about 3.5 gigabytes per second. I go back, just change to MM in front of it. That's how you use the memory machine, and then you can see the performance using our software with memory machine. Right. Again, you will see this GUI picked up. Right. So we're about 4 gigabytes per second. That's a demo of our memory machine product. Thank you.
So am I to understand that there are Intel Optane enabled instances in AWS that I could grab and use this software with today?
Not yet. So AWS and Azure and Google do not have it as a public service just yet. They're working on it. We expect it to be coming out in the near future. The first cloud service provider actually have Optane instances is Alibaba. They just launched it a couple of weeks ago. That you can get the computing instances with Optane memory app direct mode available from those instances. What Charlie demoed is DRAM only. So our software can run however the memory is underneath. It can be DRAM, it can be Optane, it can be combination. It can support future memory units as well.
Okay, so I could do the memory magic tricks of like teleporting processes from one place to another today
on DRAM also. Yeah. So this now the only thing Optane adds is it's persistent. So once we take the snapshot, we know it's persistent. DRAM, of course, if you have a crash, then you lose that snapshot. So that's the something you couldn't get from DRAM only, but the basic mechanism would work on DRAM just like it would on Optane.
Amazing.
Thank you. We are obviously very enthusiastic about this work that we are doing, and we're only at the very beginning. The earlier comment, there are many answers. We answer yes, but many of those yes requires a bit more work. And I think we're only scratching the surface on the possible use cases on this.